welcome to Pipeflow software. In this video we will demonstrate how to calculate the pump head required to move water between two tanks at different elevations. We've already loaded the system and it's shown on the screen. Let's go ahead and review the design details before we run the calculation. If we highlight the base tank, we can see the details of the tank. A surface pressure of 0 psi gauge, we have a liquid level of 24 feet, and the bottom elevation of the tank is set to be 0 feet. If we highlight tank 2, we can again see the surface pressure set to 0 psi gauge. Here we have 9 feet of liquid in the tank, and we have a bottom elevation of 280 feet. If we highlight pipe 1, we can see the details of the pipe. This has a length of 4.62 feet. It's a 4-inch pipe with an internal diameter 4.026 inches, and we have selected schedule 40 steel, and this is the roughness value. We can highlight other pipes in the system and review the length of the pipes and the diameters and the roughness. All the pipes are set to be 4 inches, and again all use schedule 40 steel. The length of this pipe is 200 feet. Pipe 3 is set to be 974 feet, and pipe 4, rising up to the top tank, is set to be 76 feet in length. If we look at the elevations of the nodes, we know the base tank is set to be at 0 feet, and we can highlight the first node and we can see the elevation is set to be 4.6 feet at this point. Node 3, the elevation is set to be 204 feet as we rise up. Node 4 is again at 204 feet, and we know the top tank to have an elevation of 280 feet. There are some fittings and bends included in the system, and these are indicated with the little fitting symbol here. We can click on this and it will show us that there is a standard bend on this 4-inch pipe, and we can see the K value that will be used to calculate the losses through that bend. Let's go ahead and run the calculation, and just before we do that we can review the pump details. If we click on the pump, we can see that the pump is set to be 0 feet along the pipe. It's at an elevation of 4.62 feet, which is the same elevation as the start of the pipe, and here we've chosen a pump type which is a fixed flow rate where we're asking it to produce 200 US gallons per minute. And what we want the calculation to do is to work out the pump head required to meet that flow demand. If we run the calculation, we click on Calculate, the system is solved, and we can review the log. This gives us some information about the method used to solve the system and gives us information about friction losses and fitting losses. We can also see that the total pump head added to the system is 295.27 feet head. There are no issues to report, and we are asked, do we wish to view the detailed results table now? If we select no at this point, we're still in results mode, and the results are shown on the diagram here. We can see from this key that the flow is shown in US GPM, and we can see there's a flow of 200 US GPM in each of the pipes, which is the flow rate that we asked the pump to produce. And we can also hover over the pump, and we can see in the yellow status bar window at the top of the screen the suction pressure of the pump 18.62 feet. The total head added by the pump is 295.27 feet, produces a flow of 200 US GPM, and the Npsh available is 51.84 feet head of liquid. So we've solved this system, and we've solved the pump head required to move the liquid from the base tank to the top tank to overcome all the friction losses and elevation changes in the system. We can also view the results in tabulated format. If we click on this results button, this shows the results in spreadsheet format, and here we have all the data related to the pipes. We're on the pipes tab. It gives us the material, the diameter of each pipe, roughness, length, K value for the fittings, tells us the flow in each pipe, the 200 US GPM, the velocity, and if we scroll across we can also see entry and exit elevation, the entry and exit pressures, and the difference in pressures. So this is a comprehensive list of information, and we can see on pipe 2 there was a pump, and the pump head added, again we see the figure 295.27 feet head. We can also click on the fittings tab, and here we have the information about the fittings in the system. We can click on the pumps tab, and again we can see the pump data. We can click on the nodes tab, and this will give us information about each point in the system, the elevation of the points, gives us the liquid level in the tanks. It also gives us the pressure at each node in the system as the pressure changes throughout the system. The fluids tab will give us information about the fluid. We can see we've chosen water, and we can see the information that's used for that particular water at 68 degrees Fahrenheit. The pipe materials tab will give us information about the materials used and the weight of the pipe, and we can also look at the energy calculations. We can show the energy results in kilowatts, and here for each of the pipes we can see the energy loss to pipe friction, we can see the energy loss to pipe fittings, loss to components, etc. And here we have a subtotal of the energy losses on each individual pipe. Finally, we can click on the All Results tab, and this will give us all of the information listed in one spreadsheet. With any of these tabs and with this final spreadsheet, we can either save this information to an Excel file, or we can click on the Excel button and the information will be instantly exported out to Excel. Let's close this window for now, and here we can see the results on the diagram again in the background. So this gives a very simple method of solving the pump head required to move the water between two tanks through a pipe system.